What if we could teach a machine to see like we do, not by like labeling everything, but by making it predict what it's going to see next?
Interesting.
That's the whole idea behind V-JEPA.
V-JEPA.
This cutting-edge AI model, it's really changing how we think about machine learning.
Yeah, so V-JEPA stands for Video Joint Embedding Predictive Architecture. And it's actually a big collaboration.
Okay.
It comes from researchers at FAIR, at Meta, Emburia, École Normale Supérieure,
Wow.
CNRS, PSL Research University, UNEF, Gustave Eiffel, CNRS, LIGM, Current Institute, and New York University.
So a lot of people are working on this, huh?
It's a pretty big project.
But the really cool thing, at least to me, is it learns without that traditional supervision. So we're
Yeah.
not talking pre-labeled images, no text descriptions, just raw video data.
Just like how we learn, right?
Exactly.
That's by observation.
So it's like how we learn as kids.
Yeah, just watching, predicting.
Just by watching things happen.
Yeah.
And the results are pretty impressive.
The results are really interesting.
Like being able to recognize,
An action.
like someone dunking a basketball.
Right.
Or even more subtle things.
Yeah, more subtle.
Like those actions that require a deeper understanding of the motion.
Okay.
Like, okay, is someone putting an object under another object, or are they putting it next to another object?
Those are pretty subtle differences.
They are.
So how does VGP,
How does it learn?
learn to do this just by watching videos?
So imagine you're watching a movie.
Okay.
Someone keeps covering up parts of the screen.
Like with blocks or something.
Yeah, with random blocks, exactly.
Right.
VGP is basically trained to predict what's hidden behind those blocks
Based on...
based on what it can see.
Oh, I see. So it's like a puzzle.
It is. It's a visual puzzle.
Okay.
And it has to figure out, okay, what are the missing pieces? But it uses context.
So is it how VGPA learns about objects and movement and how the world works?
That's exactly it.
Okay.
By playing this prediction game over and over, it starts to figure it out. Okay, this is how things work. So you mentioned that V-JEPA doesn't predict the exact pixels.
No. It's
That's what I'm missing.
It's not about recreating the image exactly.
Right, it's predicting something called features.
That's right. It's more abstract.
So what are those?
Think of it this way. Instead of trying to redraw every single detail of a chair,
Oh, okay.
V-JEPA learns the concept of a chair.
Ah,
What makes a chair, how's it different from a table?
gotcha.
How's it likely to be used? That kind of thing.
So it's learning more the essence of something,
The essence, yeah.
not just how it looks.
Not just the visual appearance, exactly.
So predicting features, why is that so powerful?
Because it's adaptable.
Okay,
It leads to a more efficient, flexible understanding of the world.
that makes sense.
Rather than just, okay, this is what a chair looks like in this exact situation.
You also mentioned a specific masking strategy.
Right, so how do we make this game harder?
Okay.
Well, the researchers, they use two types of masks.
Mm.
Short-range masks and long-range masks. Short-range, they cover smaller areas scattered throughout the video frame, kind of like little puzzle pieces missing.
Gotcha.
Long-range masks, they cover bigger areas, more continuous areas.
Like bigger chunks are missing.
Exactly, so it's a tougher challenge. And here's the kicker.
Okay.
The average masking ratio, 90%.
90%?
So 90% of the video
Wow.
is typically blocked out.
That's a lot.
It's a lot.
Yeah.
I don't know about you, but I can't imagine trying to understand a video
Yeah.
with 90% of it gone.
So how does V-JEPA, how does it even start to make sense of that?
That's the really cool part. It forces the model
Okay.
to develop a very deep understanding of the visual world.
Okay.
To predict what's hidden, it has to learn
It has
the underlying patterns, the relationships between objects,
Okay.
the movements.
So tougher the puzzle,
Yeah.
smarter V-JEPA gets.
Exactly, and that's why they test it on all these different data sets. These really challenging data sets, they look at action recognition, motion understanding, even object recognition.
Okay, so how well did it do?
It did exceptionally well,
Really?
especially on those tasks that required a very nuanced understanding of motion.
The subtle ones.
The subtle ones, exactly.
You were talking about something before.
Yeah, so it's something.
The under versus next.
Exactly.
Okay.
V-JEPA got an accuracy over 72%,
Wow. So that's...
which was better than any other method they tested.
Okay, so it's not just a one-trick pony. It can handle lots of different tasks.
It can handle a variety of visual tasks, yeah.
And what's even more remarkable is that it's so efficient.
It is.
Like we were talking about the label efficiency.
Yeah,
It's outperforming other models.
while watching way less video.
Wow, that's amazing. It's learning the core principles.
Yeah, the rules.
It's not just memorizing.
Exactly. It's learning the rules of the game, not just memorizing the moves. And to understand how it's thinking, they use this tool called a diffusion decoder.
So is this like giving V-JEPA?
It's like giving it away to show us what it understands.
It's like imagination almost.
It's a great question, and the answer might surprise you. So it kind of gives us this glimpse into how V-JEPA is thinking, right?
Okay.
The decoder takes those abstract predictions,
Those features.
the features, yeah, and turns them back into something we can actually see.
Like images.
Images, or even video frames.
Okay, so it can show us what it understands.
Yeah, and the results are pretty cool.
Like what?
Well, for one, it shows us that V-JEPA has learned about spatial and temporal consistency,
Spatial and temporal consistency.
meaning it understands that objects, they exist in specific locations, right?
Yeah.
And that they move in a logical way over time.
So wait, is V-JEPA basically understanding object permanence then?
It seems like it.
That's like the thing babies learn, right?
Exactly, like when you hide a toy under a blanket, the baby knows it's still there.
So this AI is like,
It's grasped that concept,
wow.
which is pretty amazing when you think about it.
Yeah.
An AI trained just on video data, exhibiting a cognitive ability,
That we usually associate with humans.
Right. It's learning the same basic rules of reality that we do.
That is super interesting.
It is, isn't
That
it?
AI is starting to bridge that gap between machine learning and how we humans actually understand things.
That's what makes this research so fascinating.
You were talking about datasets earlier.
Right.
We know V-JEPA was tested on a whole bunch,
Whole bunch.
including these really challenging ones focused on action recognition, motion understanding.
Right.
Can you tell me a little bit more about those? Like,
Yeah.
what are they?
Well, we talked about something.
Right. The subtle actions.
The subtle actions, yeah.
But there's also kinetics, right?
Kinetics, yeah. Kinetics 400. That's more about recognizing actions based on appearance. So things like playing guitar, riding a horse, actions that are easy to recognize based on what you see.
Okay, so that's more straightforward.
More straightforward, yeah.
And how did it do there?
It did great. Over 81% accuracy on Kinetics 400.
81%. Okay, so it's got the basics down.
It does.
But something is where it really shines.
Yeah,
Showing off its understanding of more like complex movements.
exactly. Like those subtle differences we talked about.
The under versus next
Yeah,
to.
exactly, yeah. On something V2.
Okay.
It got over 72% accuracy.
Okay, so those percentages sound good, but for those of us who aren't like AI experts,
Yeah.
what do those numbers actually mean? Like, what do they tell us about how well V-JEPA is doing?
It tells us how often V-JEPA correctly classified an action or a scene.
Okay.
So an accuracy of 81% on Kinetics 400 means out of every 100 videos it saw, it correctly identified the action in over 81 of them.
Okay.
And on something V2, with those really subtle actions, it was still right over 72% of the time.
Yep.
So it's doing pretty well.
So basically, V-JEPA is acing its visual perception tests.
Acing them.
You mentioned earlier this thing called joint embedding.
Oh, yes.
And I have to admit, I don't really understand what that means.
Okay, well, joint embedding is a key part of how V-JEPA learns.
Okay.
So it doesn't just look at the raw pixels of a video.
Yeah.
It learns to represent different aspects of the video, like the objects, their movements, their relationships, as vectors,
Vectors.
which are like points in a multidimensional space.
Okay, so it turns visual information into math.
In a way, yes.
Uh-huh.
It creates these mathematical representations.
Okay.
Now, the joint part means it does this for both the visible parts of the video, the parts that are masked out.
Okay.
The goal is to make these representations as similar as possible,
Even though they're from different parts?
even though they're from different parts of the video, yeah.
So it's like V-JEPA is trying to connect what it can see and what it can't see.
You got it. It's trying to find those hidden connections. By making these representations align, VG Chief learns to capture the underlying structure, the dynamics of the visual world.
So it's like figuring out the rules of grammar
Exactly.
without seeing every sentence.
Without seeing every sentence ever written, yeah.
That's a really interesting way to think about it.
It is.
So it's learning the structure of how the world works, not just the details.
Not just the superficial details, yeah.
Okay, so this approach, combined with the fact that it's so label efficient,
Yeah,
makes it a pretty promising development in AI.
it really does. It does.
We've talked a lot about how VGP does on all these different tasks,
Mm-hmm.
but what does this mean for the bigger picture? Like, how could this impact our lives in the real world?
The potential applications are huge. But let's start with something we all experience every day. personalized recommendations.
Okay.
The algorithms that suggest videos on YouTube or movies on Netflix, they're pretty good. But
Yeah.
sometimes they're mostly based on what you've clicked on in the past.
Or what other people who are like me, what they watch.
Exactly. People with similar tastes.
Yeah.
But they can be a bit hit or miss, right?
Yeah, like it doesn't always get it right.
It doesn't always get it right.
Yeah.
Because they're mostly relying on surface-level data, right?
It's clicks, ratings.
Clicks, ratings, watch time. They don't really understand the content of the videos. Now, imagine those recommendations powered by V-JEPA.
Oh, okay.
It could analyze the actual content of the videos, understand the nuances of the actions, the scenes. It could make recommendations based on a much deeper level of comprehension.
So instead of just recommending stuff based on what I've watched before,
Yeah,
it could recommend things that actually, I don't know, match my visual preferences.
exactly. Even if you've never watched anything quite like it before.
Like it's predicting what I would like based on what it sees.
It's like having a friend who knows your taste in movies better than you do.
Okay, I like that.
They can recommend something you wouldn't have thought to watch on your own, but you end up loving it.
That would be amazing.
Right. No more endlessly scrolling through those recommendations.
That never quite work. Exactly.
Yeah, that would be great.
It's about understanding what you actually enjoy, not just what you've clicked on in the past.
Okay, so it's not just about entertainment, right? This could go way beyond that.
Absolutely.
Yeah.
Think about education. V-JEPA could help create personalized learning experiences
Okay.
that adapt to a student's individual learning style. It could analyze how a student interacts with visual content and then tailor the experience to them.
Wow, so we're talking about AI that could personalize our entertainment,
Yep.
but also revolutionize how we learn
Exactly.
and interact with information.
It's about using AI to enhance those experiences.
Okay, but before we get too carried away with all this amazing future stuff,
Yeah, we should.
we should acknowledge that no technology is perfect.
Of course.
So, are there any limitations or challenges to V-JEPA's approach that we should be aware of?
Well, the researchers are very upfront about this. One thing they acknowledge is that the datasets, they're big, right?
But they're still limited in terms of visual diversity. Think about those huge data sets
Okay.
that are used to train some of the best image recognition models. They're trained on billions of images
Wow.
from all over the internet.
Yeah.
They cover a huge range of objects, scenes, situations.
So is it kind of like V-JEPA's trying to learn about the whole world, but it's only seen pictures from its own neighborhood?
It's a good analogy.
Okay.
There's a ton of visual information out there that hasn't been exposed to yet.
So that's definitely a challenge.
Yeah, building those more diverse, more comprehensive data sets.
Right.
It's a big area for future research.
The more data it has, the better it can understand the world, right?
Exactly. The more it can learn, the more robust, the more adaptable it becomes.
That makes sense.
Another challenge V-JEPA right now, it focuses on understanding visual information,
Okay.
but kind of in isolation. It's amazing at recognizing actions, predicting those movements,
Right.
but it doesn't yet connect those visual inputs to other things, like language
Oh.
or sound.
So it's like it's watching a silent film.
That's a great way to put it, yeah.
It understands what's happening, but it's missing
Missing the dialogue, the music.
that extra layer, right?
Exactly.
Yeah.
Integrating V-JEPA with those other modalities, that's another exciting area for research.
So we could have AI that can not only see and understand actions,
Right.
but actually describe what's happening.
And maybe even predict the sounds.
That would be incredible.
That'd be next level for sure.
Machines that can understand the world and talk about it.
It's really getting closer to how humans experience the world, yeah.
It's pretty mind-blowing.
It is. But we're still in those early stages, right?
Yeah,
V-JEPA is a big step forward, though,
definitely.
in this quest to create truly intelligent machines.
Well, I'm super excited to see where this technology takes us. It feels like we're on the verge of something really new here,
It does.
where machines can learn and understand the world like never before.
It's a thrilling time to be working in AI, that's for sure.
So much potential, so much to discover.
V-JEPA is a great example of that.
Okay, so let's bring it back down to earth for a minute. For those of us who aren't AI researchers,
Yeah?
what are some of the more practical ways that V-JEPA could impact our lives, maybe in the near future?
Well, there are a few things.
Like what?
Think about personalized recommendations, for example. You know, those algorithms that suggest videos on YouTube
Yeah.
or movies on Netflix, they're not bad,
Okay.
but they mostly just look at what you've clicked on before or what people like you have watched.
Right.
But they don't really understand the content, do they?
Not really, no.
Imagine if those recommendations were powered by something like V-JEPA.
Okay.
It could look at the visuals. It could
Yeah.
understand those subtle actions.
And it would actually get my taste.
It would understand your taste.
Yeah.
Much better than just looking at your click history.
Okay, so it's like a friend who knows my taste in movies better than I do.
Exactly.
Wow, okay. Now that
They could suggest something you never would have thought of,
I like.
but you end up loving it.
Okay, that would be a game changer, I gotta say.
Right. No more endless scrolling.
No more scrolling.
Trying to find something decent. And this could go beyond entertainment, too.
Okay, like what else?
Think about healthcare. V-JEPA could be used to create diagnostic tools.
Oh.
Tools that can detect those subtle changes in a patient's movements
Oh. Yeah.
that might indicate a medical condition. Imagine a system that watches a video of you walking
Wow.
and can alert your doctor if it sees something off.
So we're talking about AI that could personalize entertainment, potentially revolutionize healthcare?
It's all within the realm of possibility for sure.
It is pretty amazing.
And those are just a couple of examples. There's so many more potential applications for V-JEPA's technology, things we probably haven't even thought of yet.
So as this technology evolves, we could see it in more and more parts of our lives.
Absolutely, yeah. Enhancing our experiences, helping us solve problems in ways we're just starting to imagine.
It's an exciting time to be alive, for sure. This has been an incredible deep dive into V-JEPA and the future of AI, and I'm so glad you are here to help guide us through it.
I've enjoyed it. It's a fascinating topic.
But before we wrap up, I want to leave our listeners with a little something to ponder. We've talked about how important prediction is for learning. But prediction, in a way, is just another word for imagination, isn't it?
That's a really interesting thought.
That ability to conjure up possibilities, to anticipate what might happen next, that's a big part of how we learn, how we adapt, how we create.
It is. It really is.
So if predicting the future is so important for learning, what does that say about the role of imagination in our own development? How much of our intelligence, our creativity, our sense of self comes from our ability to imagine different possibilities?
Those are big questions.
Yeah.
Questions that philosophers and scientists have been thinking about for a long time. And V-JEPA's success just adds another layer to it.
It does.
Maybe the key to true artificial intelligence isn't just about processing information.
It's about something more.
It's about cultivating that ability to truly imagine.
It's a pretty amazing thought. And while we may be a ways off from AI that can really imagine, V-JEPA gives us a glimpse of what might be possible.
It does. It does.
Well, on that note, I think we've reached the end of our deep dive into V-JEPA. It's been an amazing journey, and I hope our listeners enjoyed it.
It really has.
Thank you so much for being here.
It was my pleasure.
And thank you to all our listeners for tuning in to The Deep Dive. We'll be back soon with another deep dive into the cutting edge of technology. Until then, stay curious.